All right, so hi guys, this is Jackie from techjackie.com. Welcome to another video on SEO. If you're brand new to this channel, make sure you press the subscribe button down below so when I release a new SEO video like this, you get notified, right? So in today's video, I'd like to discuss about some theoretical thing when it comes to SEO, and that is to think like search engines. Today, I'm gonna go through a couple of slides to kind of explain to you a top-level overview of how modern search engines like Google, especially, rank results. So in this way, I want you to keep this as your base whenever you do SEO, whether you're an SEO or you're a business owner. I want you to kind of think a little bit of like search engines and how Google would actually works, right, when it comes to ranking the search results. So this will help give you an SEO mindset and how to approach things, right? So first, I would like to introduce you to the rule-based versus ML or machine learning-based search engines. Generally, search engine ranking system can be broadly divided into two types. That is the rule-based, or we sometimes call it heuristic, and machine learning-based system. The ranking signals in search engine design we also call as features are curated manually. So there are basically two main types of search engines. That is number one rule-based, and number two is machine learning-based. And the features or the ranking signals are manually curated by the search engineers. In rule-based search engines, generate predefined outputs on the basis of a lot of rules programmed by humans. Here, the weight of each signal is also adjusted manually. So when it comes to rule-based search engines, there would be a set of certain predefined instructions that the search engineers wrote and give it to the machine. For example, if this, then else, otherwise, then do something else, right? So let's say we want to create a search engine for for an e-commerce brand. Let's say it sells some clothes. Then some of the set of algorithms or the rules that the programmers would be writing would be something like, if a user search for this and then if it matches this and also this. So there would be multiple conditions statements to kind of try to match, right, what the users are searching for. And this is good when it comes to small, when they have like it doesn't require large complexity, such as initially when Google was launched as a new search engine back in 1999, or even up to right around 2006. They were mostly using rule based system to rank their to rank search results. Whereas when it comes to machine learning based search engines, it utilizes what we call as learning to rank models to assign, adjust each signal weight automatically. So nowadays, more popular approach of search engine is to use a machine learning systems in which it uses an models called learning to rank is one of the applications in machine learning that essentially work automatically to assign each weight or on each signals. So you can think of it like there are like multiple features or multiple ranking signals such as page rank, anchor text, title match, all these. And all these were essentially created by or defined by search engineers. And these features or these ranking signals all have different priority or importance, or we call it as weight. And these weight changes as the machine learns, right? So let's say there's an algorithm update rolls out, and then you might see suddenly there's a jump of rankings for a website that have high a number of backlinks. So that means in that iterations of algorithm updates, the more weight was put on the page rank or the link juice feature there, right? So the most common architecture that the LTR or learning to rank model uses are called as neural networks. So in order to run an LTR or learn to rank models, they usually define a set of neural networks. So these are essentially, you can think of it like an artificial neurons in your brain, but these are like computers, and these essentially learns how to adjust different signal weight automatically, and it is using neural networks in most cases. And the learning here is, when it comes to learning to rank models, uses supervised learning. Now, what is supervised learning? In machine learning, there are two types of learning for the system, that is supervised and unsupervised. Mostly for the learning to rank models, it uses what we call supervised learning. Supervised learning, also known as supervised machine learning, is a subcategory of machine learning and artificial intelligence. It is defined by its use of labeled data sets to train algorithms that to classify data, predict outcomes accurately. So in supervised machine learning, there would be a set of data set, right? So you can think of it like, web pages and stuff like that. So these are like the set of data that are curated manually and feed it to the system, and the system learns it, and then apply the feedback and then relearns it, and this goes over and over again, right? So you can think of it like, something that has some human intervention there. Basically, humans are there to kind of assign initial data set to feed to the machine. I'll explain a little bit more when it comes to features and data set in the next slide. So as far as Google is concerned, since 2013, they have switched to a hybrid of search engine models that is combining both the rule-based and machine learning-based systems. So up until right around 2010 or 2012, Google were mostly using um, rule-based system. So there were engineers who manually assigning weights to different ranking signals based on what they think are the best search results possible. But it's not done on a every query. It is done like on a larger scale, and then roll it out, and then this applies across the board, right? Something like that. But since 2013, they had become more invested in machine learning, and they're now heavily relying on machine learning. But to some extent, some Googlers also confirm that they still are using some part of the system in rule based as well. So they really didn't like ditch rule based system completely, because there are many drawbacks of using machine learning, and one of the biggest disadvantages or drawback here is not understanding what's going on, right? Because let's say if you give 100% freedom to the machine, what happened here is you're not going to be able to you're not able to see what's going on in the background, or to understand what's really the machine is prioritizing and stuff like that. Or you cannot even debug what's going on if there's any bug or errors happening, right? It could take like a lot of times and and effort. That's why some part of the ranking system are still rule based, which means the search engineers can always go in and fine tune it on their own manually. Now let's talk about features and data set in practical scenarios. So now you understand, there are two types of search engines, and we also understand there are like ranking signals, or what we call as features, and there's also data set. Now, how do these things, apply in practical scenario when it comes to ranking your website? So features or ranking signals are basically all the SEO ranking signals that we know and not know, defined by search engineers. Like previously mentioned, features, or what we generally call as SEO ranking signals, are the things that are defined by search engineers. Some of which are known publicly, such as page rank, anchor text, relevance. When it comes to relevancy, again, there are more like specific um, signals or features, such as title tag match, and something like that, link flow in the web page, right? So your internal link. And some of them, many of them, I would say, are not also known by us. Like they're only known by the search engineers. Now, data sets in search engine design. So when we talk about data set in search engine design, obviously machine learning can be applied to all types of applications, one of which is search engine design. When we talk about data set in search engine design, they're essentially just a set of documents or web pages that are either manually created, or what we call as explicit label, or chosen automatically by the system, what we call as implicit label, to be used in training of the model, and we call this as ground truth. So when it comes to search engines, the data set here are essentially set of web pages and queries. So queries and then web pages, and then these are manually picked out by search engineers, what we call as explicit labels, or chosen automatically by the system. So these set of data that the search engineers are going to use for training the models are either collected manually or let the system collect it by themselves. And this data set is called ground truth. So essentially, ground truth or these training data sets are essentially what you can call like a pure data set, or what search engineers really want every website to kind of replicate these set of web pages. So you can think of it like the most authoritative, the most trustworthiness, the most relevant web pages when it comes to specific type of queries. So you can think of it like there are like multiple people who does a search for some set of queries, and then they pick out certain web pages for different type of queries, and then these are fed into the systems to kind of let the system learn. And these web pages that are manually picked, or either manually or automatically picked, are what the search engineers really want the web to be. You can think of it like a role models, or what search engineers really want all the web pages to be across the internet, right? Okay. So as far as search engine design is concerned, there are two ways in which data set are collected. So when we talk about data set, there are two ways that are generally, discussed. There is number one, a set of defined guidelines, and number two is click satisfaction feedback. So when it comes to what search engineers would use, or a criteria of how they would select a data set, are either number one, from a set of defined guidelines. So search engineers or companies would publish a set of defined guidelines or instructions to give to people, many people, and let them follow instructions, and let them pick out what they think are the best, most useful results for those certain set of queries. And secondly is to use clicks or satisfaction feedback. So in order to know like which documents are good, they can also use click or satisfaction factors, like if a user click on it, users spend some time with, some dwell time is there, stuff like that. And also let the machine pick that and use that as a set of training data set as well, right? So as far as Google is concerned, these defined guidelines is referred to as nothing but the quality raters guidelines, right? So if you think about it, when it comes to Googlers actually, picking up set of search results or pages to use for training the machines, these are essentially nothing but what they actually define the quality rater guidelines, right? So they publish this out in the public, and all the quality raters are assigned this same documents where they use to rate all the web pages across multiple queries. And they got the feedback from the search from the raters, they feed it to the machine relearns it, and that is where the machine updates all the ranking signals important or the weight, right? So that is what we generally see in every update, especially core updates. So mainly Google relies on quality raters to kind of help define what are the best type of results, right? Whereas clicks and satisfactions feedback have also been open to the public, that they use it to test experiment whether they release any new features. So Googlers, many of the Googlers, some of which like Gary Illich, have also confirmed that clicks and satisfactions are also used, and user interaction with the search results and web pages are also used as a experiment to see whether or not their new features are giving the satisfaction, right? Are they satisfied with the results or not? So let's say a Googler, let's say search engineers roll out an update. Let's say they roll out a core update, and then over the the course of 2 to 3 weeks, they would run multiple experiments to see whether or not the updates really satisfy what they're looking for. And one of the ways is they look at it across the entire web, by looking at the clicks and user interactions with the results. So that's why sometimes we see rollback in the core updates, right? Because maybe after certain tests they might not be satisfied with what, like, people may not be satisfied with the new set of algorithms introduced. So what they do, they rolled out the updates, they fix some of it, and then they reintroduce again. So this is essentially how it works. So to conclude, basically not to conclude, but to show you in a visual way what Google could possibly be doing here. So on the leftmost hand side, you can see there are some training data. So these are collected mostly from the quality raters. So quality raters are, across the world, are given that quality rater guidelines, and they rate different search results based on different queries, and then they submit the feedback or what they think are the best web pages for those set of queries. And this essentially will be used as the training data to feed to the next step, that is the neural net. As you can see, so these small circles that I'm highlighting here, these are essentially the features or the ranking signals. So different features are fed into this neural net, or we generally call it like a black box, because we don't know what it's doing. It takes the input as the training data, as well as these ranking features or the SEO ranking signals, mix them together. You can think of it like a grinding machine, and mixing everything up together, and then compute what we call as scoring models. And this will be released as an output to generally re-rank the entire search. And then they will also run an online experiment, or here the click experiment, to see what is the feedback. And then they feed it back to neural net, rerun it again, and then create this scoring models. And then also there will be a feedback, maybe by some search engineers who provide some feedback, and then feed it back again and rerun again. This process go over and over again until they get what they want, right? Like they get the desired type of search results. And maybe these weights are also adjusted manually by the Googler's engine as well. Like I mentioned initially in the first second slide, that Google is still a hybrid search engine. Means some part of it is still rule based, means that some part of it are also able to adjust manually as well. So maybe some of these ranking weights can also be adjusted manually. Let's say if the results produced by the neural net here, or the neural networks, are not satisfied, they might intervene the process and jump into, by manually adjusting how important each of the factor is as well, right? Okay. So what are some of the key takeaway here? I hope you understand, how everything kind of works together. So let me kind of sum up, what essentially this translate into SEO. So first, when we do SEO, we have to make sure to keep in mind the ground truth, or quality rater guidelines, as this defines what the outcome search engines like Google want. Every major search engines, whether it's Bing and or Google, have a set of defined instructions that they give to the quality raters in order to create a training set for the algorithms. And as I said, this is called as ground truth. So when you do SEO, you have to keep in mind the quality rater guidelines or the webmaster guidelines. And because these are essentially what the search engineer wants at the end of the day. And that's why they keep on iterating and releasing updates over and over again, because they want to make sure that their algorithms produce the result that they desire from the quality, from the guidelines. Secondly, we cannot possibly know what happened in each update, because the training and the updating of each weight is done automatically. Although to some extent, search engineers would have some ideas on which features are boosted in each update. So when it comes to diagnosing each of the Google updates or any algorithm updates, we should not do that, because at the end of the day, those are like, like I said, some of the ranking signals fit into a neural network, and also some along with the training data set, and mix mix and match everything up together and produce some output results. Here we don't really know what each of the updates really targets, right? We can know to some extent by looking at some correlation data, but we will never be able to know which specific features or ranking signals are getting boosted or getting reduced, because even the search engineers Google themselves say that they don't really know what's going on in the ranking algorithm there, because everything is just mix and match and produced automatically by the machines over and over and over again. So this is one thing also to keep in mind. And lastly, consistency is the key here. You have to keep on feeding the algorithms what it needs in order to convince the system that your site matches the characteristic of the ground truth as much as possible. So when it comes to modern search engines that uses machine learning mostly, like Google or Bing, you have to be consistent in your effort, right? Because you have to be able to convince that every section of your website, every part of your website, every ranking factors on your website are high quality enough, and that it will be able to eventually convince them that your website matches what they're looking for, right? So let me give you a small example of how this actually works. So let's say if I open up this. So this is a research project by Bing, Microsoft Bing, on learning to rank data sets. So fortunately, Bing was kind enough to release this publicly, so it's one of their projects. It doesn't mean that they use this for training the algorithms to rank, but here we can see they have released these are like the data sets or the set of documents which they got from the quality raters and are and will be fed to the machine learning to the neural nets. And these are the feature lists or the ranking factors that were defined based on modern search engines. So things such as some of minimum of term frequency. um, you can see, so many of these are relevance factors, such things such as term frequency, document frequency, all those. So things like some of these are not really something that you would understand, but some of them are very obvious things, such as length of the URL, page rank, site rank, quality score, URL click count. So all these are ranking features or ranking signals that are defined in order to feed into the neural nets along with the data sets here, right? So these are like this is an old one, but this kind of gives you an overview of how this would look. And then if you look at Bing Webmaster Guideline here, it's really interesting that they pointed out this exactly as well. If you read this paragraph, for web ranking, this means building a model that will look at some ideal results to learn which features are most predictive of their usefulness, relying on automated signals like user interactions with Bing website and training data labeled by human judges. You can see, so being clearly stated in their guidelines that they rely on both user interaction with Bing website. So this is essentially what they refer to as a click satisfaction feedback, as well as the training data labeled by human judges. So this refer to Bing's quality rater guidelines. So Bing clearly state in their webmaster guideline here that they use both of these to essentially um, to make sure that evaluation aligns with Bing ranking goals. So ranking goals, like I said, set of ideal result that they want to see, and then the training data set, and then ranking features all combined to neural net, and then that machine learns, produce out some results, and then run some feedback on it, and then retrain it again, and then until it gives a certain satisfaction results, right? And then they stop the rollout. So this is essentially how the modern search engines work. And I want you to keep in mind, especially these key takeaways. You have to make sure you optimize, make sure your website has aligns almost ideally with the quality raters. So you have to work backward and think, okay, one of the thing that quality raters says is is this result high quality enough? What really defines quality here? You can think of it like, maybe some backlinks define the quality. Maybe reviews might define some quality as well, right? So whatever you could think of, make sure your website stay on the top in terms of quality. Make sure your website stay on the top in terms of relevance. So you can always look into quality rater guidelines and see what are some of the things that search engines are looking for, and work backwards and think what are some of the specific things that I should do on my website to really matches what the search quality raters is looking for, right? So I hope this kind of gives you more or less some of the background of how things work, so you can have a good mindset when you start doing SEO for either your website or your clients. So that's all for it. If you have any questions, feel free to leave them in the comment section down below. And um, thank you for watching. See you in the next video.